So let's start the class by actually doing some of few tricks before we make our move into the proper design interface. So the first thing, or the first task ahead of us, is bringing in our survey data, which form the base on which our design is to be implemented. So like I always tell people, like if you are starting with the software fresh, by a starter or a beginner of the use of these tools, there are basically two ways to bring in our survey data, which are: one, bringing in the points directly as point file, and two, creating a survey database. So we'll be we'll be expecting these two ways of bringing in the survey database. So as long as maybe when you get along with the software, you tend to explore the other ways of actually generating or bringing in survey database to actually start your design in Civil 3D environment. So the one we'll be doing first is actually doing the survey database. The next one we take on is importing our point files directly into our Civil 3D environment. So yesterday we were able to copy out some files for you to actually check. Then we'll be checking up those files now, see how the files are, because we assume the files were given to us by our surveyor, who must have gone to site to pick this survey data, which we are going to base our design on. So firstly, I'll go to my desktop where I save the survey data file. I need to open the survey data file, which I call Civil 3D training class 2. You can see at the back of the file name, the file extension format is there, PNEZD. That's the extension format it came up with, and here this is just the listing of the point files, of the points. You can see the coordinates, the northing, the easting, then the elevation and description. So that's just what the PNEZD. So subsequently your surveyor might actually give you the point in another format. It might actually be the easting, northing, Z, depending on how the point is being given to you. So you actually follow that format, because the format is very, very important for you to bring in these informations into your Civil 3D. If not, you're actually going to be projecting a different information entirely in your Civil 3D environment. So having checked the point file, I will close this and go back to my Civil 3D to start the operation of bringing in this point into my Civil 3D environment. Number one, I want to start by actually creating a survey database. So to create a survey database in Civil 3D, by default your Prospector tab might be the active one. You switch to your survey tab. No, you click on the survey tab here. So by switching to your survey tab, you want to create a survey database, which will actually form like a bank for you to actually call on survey data anytime you need the information. So I click on new local survey database. So it will ask you for the name you want to give your database. Always give a name that actually corresponds to your project name, or a name that is actually related to the project you want to work on, so that you don't get lost. If you have a series of databases like I have on my own system, I have so many databases which I can actually relate it to a particular project file, as the case may be. So I might give this just AB. I give it a name AB. That's the database name. I click on OK. So once I click on OK, I give the software some minutes, not even up to a minute, some seconds to actually generate that database. So after clicking on that, you can see on my left hand side I have my AB database being generated, but there are no information in this database yet. So all I have to do is to bring in my survey data, as I've shown you outside, to bring it into this database, so that I can have it being saved here, and I can call them up anytime I actually need to make use of it. So import event, you go to your import event, then you click on import survey data. You select your AB, you click next. So the data source is asking, is it field book you want, is it land XML file, is it point file, or point from drawing? So like I said, we are going to be using the point file. We select the point file. So we need to add the directory where the point file is saved. So you click on the plus sign, you locate the directory where you saved your point file. Where you saved out your point file, you locate the directory, look for where you saved your point file. Where did I put my own? On desktop, Civil 3D, CAD training files. I locate my point file, I open it. So once I open my point file, then I select the corresponding point file format, which is the PNEZD. So you can see the preview at the bottom, whereby you can see if you're actually picking the right format.
Space delimited?
Yes, space delimited. So whereby you can see the right format of your point. You can see the northern, eastern, point elevation, and the raw description. So once you are good to go, all you just need to do is to click your next. In this particular survey data being given to us, there is no line work being done in this survey data, so that's why you don't see anything being under the specified network description. So all you just have to do is click on your next. Then the import options just give you the summary of what you have actually specified earlier. So all you just do here is just click on finish, and you allow your database to be created. So after clicking on finish, you notice some changes in your database. Like now, my import event already has an information stating Civil 3D training file. That's the name of that point. That's the file name of the point. And if you go to your survey point, initially there wasn't a black dot right in front of your survey point. And let me just give you this. Anytime you see any Civil 3D structural tree and you see a black dot right at the front, it's telling us there is an information embedded in that particular item. There's an information embedded in that particular time. Initially we were not having a black dot in front of this survey point, but now that we've imported our survey data, we now have this. And then if you expand your survey point group also, you can see you have an information under that particular one. So at this point now, I might decide to call in my survey data into my Civil 3D interface. I might decide to call it out. Either way, I can do anything now with my survey database. It's already set up and it's good for me to actually execute. So to bring it into my survey, into my Civil 3D environment, all I just have to tell this program is insert this into my drawing. So once I click insert into my drawing, it brings in my survey data. So you see your survey data being displayed based on the point numbers and the elevation. These are the label styles is adopting, the point numbers and the elevation. I might decide to tell my program remove from drawing. I'm telling my software to remove all this from my drawing. But once I click on remove from drawing, it didn't actually remove it immediately because it has actually dumped the the data into my drawing interface. So all I just have to do is go to my Prospector and definitely remove all these points. But me using remove from drawing here has disengaged the connection between my database and this drawing. So if I'm deleting this, I'm not deleting the database. So I'm just deleting these points only. So that's just how it works. So I've already said the database should remove the point from drawing. So if I decide to delete this from Prospector tab, it's not going to be affecting what I have in my database. So I go to my Prospector, I go to my point, and to all points, you can see at all points I tell it delete point.
You want to point, right click point?
No, at point, yeah, right click point. You're supposed to bring up all points under point groups.
Under point group.
There's nothing under a point group. Let me see. Select. Click on select. Yours is, maybe it's because it's a newest release.
I think I should, no, it doesn't work. I think I should have to press.
Oh, your delete won't work. Maybe it's marked. because initially, assuming you will get it right, your all point group is supposed to be active. So from all point, you just right click and tell it to delete. Like now I don't have anything, so that's why it's telling me update. So that's one way of bringing in the point, as well as go back to the survey again. I might decide to call it out again, bring it back, and then delete it. You can see, okay, I have this now. Remove, yes, go back to my prospector. Under my all points, I just do my delete. It's off. So that's one way of bringing in our survey data. So another way of doing that is actually doing it the what's called the conventional way. I call this the conventional ways because that's one of the ways I actually tell people to make use of, not stressing themselves using the database, because I advise you make use of database when you have a massive infrastructure project that entails different stakeholders like the civil engineers, the surveyors, the mechanical engineers, the what's it called now, maybe the architect also on an infrastructure project. So you can actually have a database to ensure collaboration on all platforms. So if not that, and you just have to work alone, so just do your thing by just bringing in your point directly. How do we do that? You go to your crane ground data panel, go to your point. So from your point, you click on point creation tools. So once I click on my point creation tools, then I have several icons on the point creation tool command. So I click on this import point. I have to trace my point file where I kept it. I pick the point format, PNZD, space delimited. I ensure the format layout is accurate. I'm not actually creating a point group, and if I want to create a point group, I might decide to check this and then click on this to actually create a point group. I might just call this
add points to point group.
Yes, I check add points to point group and I click on this button right at the front here. So you give it a name, maybe EG, stream, data. These are the point groups of the thing work. Whenever a surveyor goes to site to pick information for us, they might be picking information based on the topographical nature of the area, based on either the what's called what they actually find, some detailed features on the field. E.g., you might go to site there, we found outcrops. You might pick the survey data of the outcrops. What's it called now? Make it out and then put it in a particular file. Go to site the next day, pick up another point information of the stream area, call it the stream data. You might decide to go again on maybe another day and pick informations representing the existing ground condition, call it EG data. So you actually group all these files, all these point for the point information according to this what's called the information you gathered. Okay, you are bringing this into Civil 3D. You want Civil 3D to understand this as my existing ground point. So you create a group for existing ground point. You bring in another point again. You want Civil 3D to understand these are my stream data being picked along the stream line. This will give you the stream information. This will give you the outcrop information. This will give you the electric poles, utility lines, and so on and so forth. So that's why they came up with the point group, so that you don't just jam pack so much points in your interface without having to categorize them. So that was how we actually have the point grouping system. So having add this to EG, which is the existing ground, I just click on OK, and I allow Civil 3D to import my point. So immediately Civil 3D imports my point, I go to my prospector. For my prospector, you see the supposed to have all points, e.g. point groups. You created the point group.
Yes.
Why is it not coming up? It's done. It's not just coming up. Because under a point group, you just have to say the AG you created. Then you see the all points. Because by default, if you are not even creating any point group, all point is a constant point group that will be actually listed for you.
Yeah. I see your points.
So I don't know. Maybe just try close the program and then you turn it on again. Just try close the program, then turn it on again.
Save changes, yeah.
Okay. Alright. So having done that, you have your all point, you have your point group you created, then but you don't have your point being zoomed to your interface. So how do you go about that? I'm just going to select one of the points and then tell my program to zoom to. So it's just going to take me very close to where my point is. So you see the difference between bringing in the points in this way and bringing in the point using the database. This actually gives you the point elevation and the point number the same way, but the display is kind of different from when you have it from the database. So that's why I always opt for this than going for using the database. So having bringing in your survey data, the next thing you always do is your surface creation. Next thing you always move to is your surface creation. So going to surface creation, to create surface, still on your create grand data panel.
You can see this from here now.
Yes, two ways, from your prospector and from your create grand data panel, and also from your menu bar. You can do it from any way, from here, then from here. So either way you like it, or the fastest one for you. So creating a surface just it's called surface in Civil 3D, but in an actual, or let me say in engineering terms, is just tend to be the contour representing the ground condition of an area. So that's how we put in our own engineering understanding, like a contour representing the ground condition of an area. But in Civil 3D is called surface, and it's built either using the thin surface method or the grid surface method. And as well as you can see the subsequent ones we have the grid volume and the thin volume. The grid volume and thin volume works when you're actually comparing two surfaces. Either you are comparing two thin surfaces or you are comparing two grid surfaces. So how does the thin surface differ from the grid surface? TIN means triangulated irregular network, while the grid means using the what we call the conventional rectangles or box to actually create our surfaces. So the TIN makes use of triangle to actually create our surfaces. So that's how the TIN and the grid surface differs from each other. So the surface layer by default, it makes use of the C topo. That's default layer. This what the surface is going to be created on. You don't have to change that. So going to the properties and the value, the name, you give your surface name. The professional way of giving a name is actually calling it AG surface. That's the existing ground surface. Then you always have it as AG. Description, if you want to give a description, maybe the location of your site or some other things you want us to know about this particular data, you give it the description. So the style we want to adopt, I always make use of my background. Either I use 1:5 or 1:10, depending on how close I want the contours to be like, and depending on the area or the the coverage of my survey data. So that makes me select the particular one I want. So I keep on this. On my render material, this is actually is obvious whenever you are viewing your surface in 3D. So I pick my sidewalk planting short grass. So you click on OK. Basically all these settings are what you can actually create on your own. All these 1:5, 1:10, 1:20. At long run, once you get used to the software, you can create the contours spacing at intervals you like. I might have my intervals to be 0.5 by 1 meter, 0.2 by 1 meter, depending on how I want my intervals, my contour interval to run. So one thing is creating the surface, and that thing is loading the information into your surface. You expect a change to actually occur immediately you created the surface, but nothing is actually coming up. So all you just have to do is go back to where you created the surface. On your Prospector tab, you go to your surface menu. On the surface menu, you expand it. There you see the surface you created, which is AG. Then you expand that again. Under that, you see mask, watershed, and definition. Then where you are going to is the definition. You expand the definition tree and you go to your point group. Go straight to your point group and you add your point group to your survey data. This time I'm picking on all points, or I pick on my AG, depending, because it's still the same number of points that is in my AG that is in my all points. So I pick on that and I click on OK. Apply OK. So immediately I do that, Civil 3D understands the command and then generates my surface automatically. So at this point, I might decide to turn off my point, because I might say, okay, I don't want to see my point. I've already created my surface, which is basically what I'll be working with from this point forward. So I might tell my Civil 3D to just help me turn off my point. So how do I come about that? I go to my Prospector tab. Under your point group, the point group AG, I right click. I go to the point group properties. Then the point style, I turn them off. The point label style, I put them off to apply and open.
Under AG, you restrict.
That's point, not surface. Go to properties. Under point style, you are still under the information tab. You go to your point style, set it to none, then to your point label style, set it to none, apply OK. So at this point you'll be able to see your contour, which is a representation of what you had earlier with your point, easting, nothing, and so on and so forth. Eventually I did draw more on the point properties, whereby you can actually play around it, have different labels, but I expect maybe you've actually gone through that. That's why I didn't do much more about that, just to actually move forward and achieve the aim of this class. So we have our contours being displayed for us. These represent the ground information of the area. From our knowledge of geography or basic survey information, from there you can actually interpret what is actually happening around areas where we have the close contours at this point, and you have rings like this, and you can understand when you have a contour like this, like a ripple form. Those are the places where you have depressions, and where you have these are where you have the uplands, where you have the highest point in the area. So that's how we actually interpret contours, and so on and so forth. So how do you go about this now? The next thing we always move into is the surface analysis. One thing is actually generate your surface, and another thing is to actually analyze the surface to see what is actually happening, what you can actually pick out from the survey data they gave you without eventually going to the site. Without going to the site, you can actually pick what you want from your surface analysis. So how do we go about surface analysis? You right click, you expand your surface. This time on your Prospector, expand your surface, then you go to your surface name, which is surface AG. You right click and go to surface properties. So once you come up with the surface properties, there are 4 tabs: information tab, definition tab, analysis tab, and the statistics. So on the information tab, you have the surface name, the description, then the default styles. You have your surface style, where you have your contour, which we selected 1x5, and then the render material, which is selected planting grass short. So those are just that, and then at this point you can decide to change your contour to anyone if you feel like okay, you are not satisfied with having 1 by 5, you want it 1 by 2 by 10, you want it by 5 by 25, and then to anyone you actually want.
What's going to do this contours 2 meters thin background and 2 10 meters?
Yes, that's a nice question. Asking the difference between the 5 by 25 meters, 5 meter by 25 meter background and design. If you look at our background makes use of the same color layer, but you understand the major contour always occurs like what we have it at 1 by 5 meter. At every 5 meters you have your major contour, while at every 1 meter you have your minor contour. So look at what I have on my screen here. This is a major contour which is very thick and lighter than this. This is the minor. You can have this major, and I go 1 2 3 4, that's another major. I go another 1 2 3 4, that's the major. So you have the minor at 1 meter, while the major occurs at the 5 meters. So in this design you'll be having different color. Here we have the same color, it's just the dark ones and the light one that makes it different. If I change this to designer, let's add it to designer, see still the same 1 by 5 meter, but this time design. So you can see what I have my major contours at green and my minor at maroon color. So that's just the difference between your design and actually background. So design, you have it distinct for you to actually identify the major contours and the minor contours, whereby on the background they are just like the dark ones representing the minor and the light lines representing the major contours. But in our presentation we always have it background. We don't always have separate colors. Like in most contour drawings you see this is the color, this is the default or the standards which we actually adopt. So are we good to go? Yeah. So going to the analysis, surface properties. I was saying I already explained what we have on my information tab. Then to the definition tab, here you can actually see the list of operations you carried out to actually create the surface. The only operation type you carried out is to add our point group. So that's the only thing you see listed here. If I should uncheck this and apply OK, it's going to the command is going to be disabled. So therefore I won't be having any surface being displayed on my interface.
I don't allow this.
Which one?
Like the color.
You don't have? No, on the definition. I'm not on statistics now. Definition. Yes. So that's just that. So going straight to analysis, which is why we come here. On the analysis tab, you can see the various analysis we can carry out on our surface. We have contour analysis, directional analysis, elevation, slope arrow, user defined contours, and watershed analysis. Basically, we'll be doing 3 of this analysis. We'll be carrying out elevation, slope, and then the last one is watershed. You can as well carry out some other ones at your leisure time, but the basic ones that we actually work with are those ones: elevation, slope, and then watershed. This gives us the understanding of the terrain. We know the possible flow or the possible direction of flow of water. That enables us to actually do our other designs such as water hydraulic structures and then the culverts and so on and so forth. So first one we're going to go with is the elevation analysis. I select elevation analysis. On my legend, I'm picking the elevation legend, which has been picked by default for me. I'm not changing that. So create ranges by, just like we used to have in what's it called, in our graphs, or let me call it in our maps. We always have like a legend map by our right hand side, which tells us the information on the map. Same thing goes with this. So with 3D we actually band our analysis into various segments, which we actually use to understand or interpret what we'll be having on the resulting analysis. So for you to actually use the number of ranges, you tell it if you want it to actually give it 10 segments, you want it in 10. If you want it in 8, you leave this to 8. But we always have it in 10 segments, so it's going to give our analysis in 10 varying segments. So if you want it to run it by interval, you pick interval or by little, but the best practice is to have it in range. So once I have it in 10 range, then I click on my analysis button, which is this, to run my analysis. So immediately I run my analysis. The program has a glitch. I call it a glitch because it makes use of almost near colors to actually give my segment. So I take the stress of actually making the colors different, so I can actually interpret them on my layout. So that's what I always do. Just click on that just to make the color different. So having done that, I'll click on my apply and OK. Having done the analysis, change the color, I click on apply and OK. Sorry for that. I click on apply and OK. But I notice I have no change on my on my layout, on my drawing interface, my workspace rather. There's no change on the contour or on the surface. So how do we come up with that? You just have to go back to your EG surface, right click. This time we are going to edit surface style, not surface properties. Edit surface style, then you go to your display tab. On your display tab, you turn on the light for elevation because you actually did elevation analysis. So you have to turn on the light, the visible light or the layer for elevation to be visible. So I do that and I click on apply. Okay, so this comes up on my drawing interface. So at this point I can actually see the whole analysis being carried out, and it's well bounded for me to actually tell or interpret to my client. Okay, from here you can see, going back to my this thing, from here I can actually see, okay, the highest point, which is the black, the dark blue area, okay, dark blue area, which is the highest point, you can actually see it on your interface. That's dark blue area. Same thing goes with this. So let me click on OK. If you having to save yourself the stress of having to check the highest point and lowest point from your surface properties, and then you want to be checking and zooming in on this, there's something we always call the legend. You can actually display the legend by the side of this for your analysis. So how to do that? Just go to your annotate, go to add tables, and then you go to add surface legend table, not surface legend table. So once I click on surface legend table, it's asking which one do I want to add. Is it the elevation or which one? Then I select elevation. Do I want it to be dynamic or static? I want it to be dynamic because if I make any change, I want it to update automatically. So I make it dynamic and then I drop it. So you can see the legend by my side of the table. So that's how that works on the surface analysis. So the next analysis we'll be carrying out now is slope analysis. Then going back to your surface properties, from the analysis type drop down, pick on slope. I pick on slope. The number of ranges, I might leave it to 8. And I run the analysis the same way I did for the surface. Do the same thing for this one too. So I click my apply and OK. Subsequently, this also doesn't come up immediately. I just have to do the same operation all over. Go to edit surface style. I turn off the light for elevation, then turn on the light for slope. You turn off light for elevation and turn on the light for slope. and you click on your apply and OK. So these are the slope elevation analysis result comes up for you. Unlike the elevation result, his own shading is kind of different from elevation result. So this is how it comes up to actually identify the highest point and the percentage of slope. All these are just showing us the percentage of slopes on this area. To actually display the table also, add that, then this time slope, make it dynamic, then I just drop it right below this also. So you can see these are just showing us the minimum slope and maximum slope within all these areas. So that's just how they work. So the next analysis is watershed analysis. Like I said, this enables water engineers or hydraulic structural structures designer to have a pre-knowledge of the direction of flow of water in this particular project site. So they must have already
for drainage.
Yes, not for drainage design per se, but it gives you an understanding of how the area looks like, where the possible direction of water goes. So you definitely use that to design your drainage. So once you have an understanding, like, okay, the water in this area is actually flowing in this direction, then you don't have to now design your drainage to flow in the other opposite direction. So that's just how this works. So they say merge depression into single drain when a minimum average depth is less than. So for every hydrological report, they always give you the lowest point and the highest point. Like, so if you have an idea of the lowest point, you input the value around it. Maybe the lowest point of that area, whereby there is a catchment basin from the hydrological report. Maybe they've carried out the report of that area. You input that value. Let me assume for this to be, let's say, 12 meters. No, 12 meters more. Let me say 8 meters. Then if I run my analysis based on this, I should run my analysis based on these 8 meters. So anything less than this, I said merge the pressure into single drain when my minimum average depth is less than 8 meters. So the program understands to merge this into single drain.
I should run it, sir?
Yes, run it.
6 or 8?
8, I put 8. So the same way we did for the subsequent ones, you have to go turn the light on for watershed analysis.
Did I merge adjacent boundary?
No, don't check that. So I click on my watershed, apply. So you can see what we have here. Go check what they have on this layout now. This gives you the watershed analysis, giving us the direction of flow, possible area that will be water accumulation. Those are the places you have those blue shades, and then where you have the red, those are the places where you have. And these are depressions. Everything is being boundary segments. So you see the label has been arranged out for you. Boundary segment, drains. You see drains, you see depressions, you see all of them along the line like that. So the depression, which is the green, along that part, that's where the water flows to actually go into where you have it as basement. All the segments like that. So from this view now, I can understand, like, by direction of flow from here. You can see where my cursor is. There's every chances that water flows from here outwards to these boundaries. So the flow is along this part outward. From here to, there's a possible accumulation of water around here. They flow out to the extreme end, out from the uplands, because this middle are uplands, so that's why you have all this. So when there are so many things they still need to read into this to actually get a full detail analysis from this, but these are just the preliminary analysis.
Do you do tables for watershed?
Yes, do tables too. You can add tables for watershed. I say watershed dynamic. There's table for watershed. So you can see all the drains, the multi-drains, where the water is being drained to, the depression, the segment, and then the boundary point. So that's just that. So that's that about the analysis. If you have any questions based on the surface analysis, I didn't go in depth into the surface styles, surface properties, because I assumed that might actually be treated. And if you have any question on that, you can actually take me back so I can buttress my point to actually explain all those ones before we move ahead. Are we good? Okay. So I don't need all this now. I just need to get them off my screen. Off my screen, turn off all this analysis layer, turn on my watershed, and to leave under my contour.
Turn off them.
Yes, you can turn off the watershed. Turn off the watershed. Okay.
And actually division.
No, just apply it. Just go back to we are going back to our default content like. So at this point you actually understand what is happening within the project site. You have an overview of the land formation. You have a little bit of understanding of how things are going on the site. But one thing we always do, like I always tell people, there is something. This is more or less like a software work. You might decide to actually cut a section across the site, like I have on my screen now. I use my basic AutoCAD line to draw lines across this site. I want to have an overview of how the whole land is across that particular area. My line passes through this project site. I want to see the land formation. I want to see, we always call it section, taking a section of the land across that part. So how do we achieve that? Is just merely by displaying a profile along that part. But to achieve that, you just need to convert this line to be an alignment first. Without that, you can't actually achieve that. So let's do that. Getting a profile of this particular project site. So I need to convert this line I drew across this to an alignment.
Can't you do the
So what?
How do you do the two lines at once?
No, it's not advisable to do the two at once. You just have to do this. Create from objects. Accept the direction. I pick it as miscellaneous. It's not a center line, it's a miscellaneous. Call it section. I'm not using any.
What name did you use?
Section. No labels. Section, no labels. Basic alignment style is basic. So I want to check add curves between tangents. And I'm just taking a section. I want to check add curves between tangents. I'm just taking a section. I'm not doing the full design. So once I pick that, this line has been converted to an alignment. You think there's no change, but there is. So you can also do for the other one too. Go from object, select that direction, stay the same section, basic, no label, no label. So now let's just create a typical profile of that particular line. So I click on create surface profile. We have two alignments. Click on the first one, which is section 1. The select surface, you select the AG and you click on add. Select surface, that's by your right hand side. Then you click on add. Then you click on draw in profile view. You don't need to do any other thing here. Just click on, because you just want the section, just click on create profile view. Click on create profile view. So immediately you click on create profile view, you can see
then I need to reduce this stuff.
the only way to reduce this is actually to reduce this. You can see the way I'm doing it automatically is being updated on the interface automatically. So also you generate for the other ones, for the second one rather. Profile view, surface profile. View surface profile. This time you select the other one.
The first one I did for section 1.
Okay, you did for section 1 the first one.
Yes.
And then you pick on just section 1 this time. So this gives you the information about the project site along the particular line you took that street. So this just by the way, I can as well do without this now, because I just wanted to have an overview of how the land looks like around that area. So and this is what we actually have, and the full span of the full stretch is 3 kilometers. That's the full stretch of a particular area. That's about 3,000 meters. So all I just have to do is to delete this now. I don't want them. That was just for like an explanation how to actually have that. So having done that, then the main thing we actually want to tackle or to work on is actually to bring in our planned layout. Sometimes you might have the challenge of having having to walk on a virgin road. So at that point you don't have a planned layout. You have to walk along with your survey information. So in that case, you might not have this data information giving you a coverage area like we have on our screen. The information that will be given to you will just be a linear data, giving you the center line and the right of way of the road. So in situations like that, all you just have to do is use your polyline to connect the point representing the center line with your polyline. Then you just do the operation we just did now by converting those polyline to form your road center line alignment. So that's just the basic difference between using your survey data as your guide to generate your center line and then bringing in a planned layout. But for this particular period, we will be bringing in our planned layout, which is what we have here. Let's open a drawing from that folder I copied for us. Car training. see, it's called I think it's called Civil 3D Training Class 2. So we call it Civil 3D Training Class 2. Right there, what we say is a simple layout of the development. This is always being given to you by your planner, and having in mind your planner actually worked on this based on the survey data your surveyor produced. So it's not like this an abstract thing. So one thing is, you actually want to work on an infrastructure project, basically your surveyor must have been mobilized to site to give you an information of how the site looks like, the existing ground condition, then transmit the survey information to the planner, who will then plan based on the information he has from your surveyor, then transmit both the survey data and the planned or the land use plan to you, the engineer, who is going to do the infrastructure design, from the road to the storm and sewer to the drainages to the bridge, every other thing that might be entailed in the design. That is when you actually come in to do your own work. So looking at this now, all we just have to do is, because this is geo-referenced and this is planned according to the survey data, so if I'm taking this into my design environment, it's going to fit in properly on my survey information, because I'm rest assured the planner actually used the survey data to plan for this. So I have no doubt, except the planner did otherwise, that's when I'll be having conflict with this information on my survey information.
So this stuff, this is what the person wants.
This is the layout, like a typical layout. In the situation whereby you actually conceived your own idea, then you actually can generate your own layout based on your conviction, like this is what you want, this is how you want it.
Yeah, so our job now is to create this on that our surface.
You are not creating, you are just taking this to your surface.
Listen to the
Yes.
surface.
You call it superimposing. So all I just have to do is to copy this. You will not be using the normal copy, but you'll be using the copy clip. I don't know if you know the difference between normal copy and so at this point now I'll just go to this, I right click, I go to my clipboard copy, then I select, go to clipboard, and I select copy, just copy. So I go to my design environment, then you see what we have here on the clipboard. Go to your home, go and select your home tab. Home, home, yeah. So you go to your clipboard, then you click on paste to original coordinates. This is your clipboard here. Paste to original coordinates. So once you click on paste to original coordinate, what happens? Your planned layout sits on the particular survey information you had earlier. Don't be surprised, like the other part of the survey data is this is a real project which I actually cropped out. So the other part I actually cropped it out, so I don't have the full. Yeah.
So how did this one like launch here? Like, is there something similar visible to it?
Yes, like I said, the survey. This is being generated based on the survey.
Okay, so when the guy did this one,
Yes.
he already had the points already.
Yes. You know, when your surveyor moved to site, capture the survey of the whole area in question. There's something called demarcation survey, and there's something called topographical survey. So he's going to give him the demarcation survey. The demarcation survey will give him the perimeter of the project site in question. So once he gives him the demarcation survey, the planner has an overview and understanding of the land use he has. Maybe he's having 100 hectares, he's having to work with 200 hectares. So at long run, maybe the surveyor now went to pick the topographical survey. The topographical survey now gives the planner
It's just
the
like
full understanding of how the ground looks like. Like now you can see the planner actually told us, even from us, from your survey when we were working in 17 environment, we already saw that there was a depression around there. So this man actually told us, like, it's true. He confirmed to us that there's a stream flow around this area. So that's just a confirmation of what they gave us. So at this point now, you already have an understanding, like there's going to be a culvert depending on your geological report, or a river bridge along the road. So those are the things we actually think about. So if you have any other questions, you can actually come. I always use this to actually train people, because this is the peak of what you can actually face, like the peak of the challenge you can have, and while you're working with stuff like this.
Okay, it's just like that stuff we talked about yesterday.
Yes.
That's what's it called? That chapter.
Okay.
On design.
Okay.
The video showed me the architect did it on a flat surface.
Yeah, they assume a flat surface for the
That's
design.
the demarcation. He used the demarcation survey to do that one.
Can I say they use this demarcation survey? Yes, I can put it like they use the demarcation survey. They didn't do a survey at all. All they had was a layout. There's a difference between demarcation survey. There's a difference between layout. I might decide to tell you that, okay, this is what's it called now? We call this cadastral. There's something we call cadastral survey. Cadastral survey basically works with plots. They tell you, give me a cadastral survey of this area. That's the beacons. So if I know the beacons here, then you can know the extent of my plot, so that I don't encroach into another person's property. That's like a property layout. That's cadastral survey for you. So demarcation survey is actually giving you a full details of the swings, because every line of your property has bearings. It will give you the bearing, the distance, as in it will give you the detailed swing of your property lines, so you don't eventually encroach. It gives you the volume where you are actually sitting on, as well as now give you then go ahead to do your topographical survey. So that's those ones, they actually have a layout, and then they assume a flat ground and they put their design model on it, and then that's how architects work. It's eventually when they actually go ahead to do a detailed design, that's when the engineers comes in. They give them the existing ground information, so they make sure to see how this will actually fit in and sit on the ground. So having bringing this into our design environment successfully, the next thing to actually go on is to actually start our design properly. So we will be coming back by just taking a 5 minutes or 10 minutes rest to start the design proper. This is a typical layout. We've successfully superimposed this on our surface. Then all we just have to do now is to commence our design. For me now, I have a list of almost even up to 12 roads. Well, we'll be taking on just 2. We'll be designing 2. Then you can always practice, because that's one thing about this. You have so many roads to practice with on your own against subsequent classes, so that we can move ahead. So first thing we just proceed with is to create alignment. Then we move into our profile creation. Then we talk about the assemblies. Then we talk about our corridor. We do intersections. Then we see how the whole thing works from there. Before you know it, you start working on cross sections and intervals, artworks. Though you might not be able to understand those very well now, but if you start to read books and then you get to pick on transportation as option, you get to understand some of the fundamentals of road designs. So one thing is, let's start alignment. Create alignment from object. Said select first line, polyline or everything. So this is my polyline. I'm selecting this. There are 2 lines here. It's being superimposed. That's why you see it telling you to select another line. So I've selected that line. I press enter or spacebar. It's going to ask me for the direction of my alignment. Now whenever you're being asked for direction of alignment, it's just like being asked where you want your chainage to start from. Chainages are incremental along an alignment. So if you want to start from here, you have to reverse this arrow. If you want to start from here, you accept this arrow. So if you want to reverse this arrow, you just press R, enter, and if you want to accept, you just press enter only. So that's just the criteria. So now I'm accepting this direction, but I want my chain to start counting 0 from there downward. So I press this spacebar, enter. So at this point I give it name. I call it, that was road 1. Give it road 1. The alignment type is not miscellaneous this time, it's a center line. It's a road center line. If you want a description for it, to give it a description. You can see the starting station. By default, the starting station is always 0. But there are some times whereby you want to design a road whereby your chainage doesn't have to start from 0. Maybe it's a continuation of a particular road corridor, so you actually input the end of that corridor here. So it picks the other what's it called now, nomenclature, or the numbering continues from what you inputted. So well, now is left to default, which is 0 0. So the next one should be 1, like that, and it keeps counting like that. So we are having no site here, so we are not putting on any site. The alignment style is proposed because this is a proposed road alignment. Here we have it to all labels, alignment label style, it to all labels.
All labels?
Yes, all labels. All labels. So you see the design criteria. Another design criteria, this tab, the speed, depending on the standard. Well, we always have standard. Federal Ministry of Works as standard we use in design. Federal Capital Development Authority, that's FCDA, and FCTA have the standard for their various road hierarchies. State ministries too has their own design speed, so you input those design speed accordingly. Like now I'm using 56 to design for this road. That is 56 km/h. So once I have that, I go back to my general to check if everything is intact, and I click on OK. So you can see the road is designed, and you can see the design speed and everything being labeled for you.
So you cannot drive above 56 km/h?
No, it's not like you cannot drive above 56. The road is designed in accordance with 56 km/h. If you are driving and speeding over 56 km/h, you know where you see the effect is when you get to this curve, because you tend to see your car skidding, like you want to skid off the road. That's when they always tell people, if the road is designed according to a particular speed and the road is straight, you might not notice like you driving off a design speed. But once you are approaching a bend and you are way above the design speed, then you notice for you to maneuver easily with that particular speed you are moving with, it won't be easy for you. So this road is designed with 56 km/h. You are running at 80 and you are enjoying the speed at 80 along this road. You can't keep that 80 speed once you get to this bend. You actually have to decelerate. But if I should design this road with 80 km/h, the curve settings you actually design along with 80 km/h so that I can maintain my design speed once I approach the curve, and I won't feel any negative impact of maybe I'm skidding off or anything. So it's not like my car must actually be. You see people, they design a road for let's say 100 km, people are running 160. That's what they say. Always observe the design. Not that you can't overspeed more than the design speed. They always tell people to actually come back to the design speed, drive according to the design speed of the road. It's not like actually you can't drive above the design speed of that particular road. So that's about that. So one thing again is the alignment label styles. Successfully we generated our alignment.
You can reduce it now.
Is that?
You can reduce it.
Reduce.
Labels.
I don't get.
Because normally, our family normally uses just.
That's what I wanted to tell you. We can actually, because the standards in outside, maybe US, UK, Canada, or any other thing, maybe they run their own in 2020. In Nigeria, our changes are always at 25 meters. Our changes are always at 25 meters. So what to do is just come here. I might decide to just run this. One thing is, let's tell people I might decide to remove my minor stations, leaving my major station alone, and I leave this to be 25.
Remove your minor?
Yes, I delete my minor, then I change my major to 25.
Which one 25 again?
That's the only one. That's 25. Apply. Okay. So if I go back to what I have here, you can see my change is at 25. All these parameters are always needed in your design, depending on what the people or the what's called the agency that is vetting your design, what they request for. All these PC point of curvature, they are always required to be displayed on your design. So you don't have to actually come here and start removing them all. No, don't just come here and be removing what. I might decide, like this one now, I might decide to turn off the design speed. I say, okay, I don't want the design speed to be displayed. So I click on apply and okay now. You see my design speed is no longer going to be displayed here. I just have this like this. Thank you. So once I turn this off, my design speed might just come in handy like this, without being displayed, but my alignment is there. So subsequently, there are other things you can actually do on your alignment label, like this one. And this one is parallel with tick. I might decide to change it to perpendicular. Perpendicular with tick. Apply and OK.
How do you change?
Just click on this tag here. Click on the tag, then click on the drop down. See perpendicular with tick. OK.
What does it mean?
And OK. You see the effect. Click apply and OK, and you see the change. You know, initially when it was parallel, your label was actually parallel along with your alignment line.
Okay, yeah.
But now it's not perpendicular to your alignment line. So that's how those things work. But by default, I always prefer to have it parallel. Yeah, I would love it to be parallel with tick, so that my other this will be perpendicular. So that's about the labels. So under the settings, you can as well come to create your alignment settings, the styles as you want it to come out. You can create all of them like that. So moving now, let's just create another road alignment, which is the next one. This one, this crescent. I want to take on this crescent now. It's a crescent.
What's a crescent?
A crescent is a special type of road whereby the access, like now, is accessing. It took access from here, goes round and exits back to that same road. That's a typical crescent.
Okay.
So the same way we did for the first one, alignment from object, select the road, press enter. It's asking for the direction. I accept the direction. I call it road 2. Center line, no description, is a proposed road. All labels. I click on my OK.
This road 2.
Yes, road 2.
Propose.
Yes, proposed.
Maybe the starting station should be 0.
Sir?
The starting station should be 0.
Yes, 0. Starting station will be 0. So are we good to go? So you can just repeat the same thing we did for the first one where we edited the label and making it 25, removing the station label, blah 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 blah, like that. So having done that, the next thing you proceed to, having designed your alignment, is your profile. You create a typical surface profile, then you proceed into generating your design profile. So what I will employ you to actually take up design books on road. So by that you eventually get a full knowledge of actually implementing a full road designs with this particular software. Not just that knowing how to use the tools, but actually saying how you can design along guidelines. There are various design guidelines and codes, just like we have in structures. We have them for highways too. So the first one I want to do now is to create surface profile. Surface profile. For that, for the road 1, you pick on road 1. Road 1, surface profile. Road 1, surface profile. Go back on now. So we select the road we want to design for. Now we have 2 alignments. Subsequently we might have like up to 10-15 alignments, depending. Like yours now you have 4 alignments. So you select on the particular one you actually want to work on, then you click on the surface, you add the surface. So after adding the surface, then you click on draw in profile view. At this time your profile view dialog box comes up. Here is alignment is already specified, don't need to pick on another alignment. The profile view name, depending, is going to the program is going to use the what's called now the alignment name to actually name the profile view name. If you find the description for it, you can select that. The profile view style, we are making use of the profile view, but depending along the line, there are ways whereby you can actually create our own style, which we actually see once we are able to finish with this now. Then when you finish with this, we go back to settings and see some other settings we can do for the day. So we'll call it a day from there. So profile view, you select profile view. For now, this is what you select, because this is just their own default profile view style. So you click on next. Your station range, you leave it to automatic. Always leave your station range to automatic, because it's going to select the start and the end of your station to design for the profile. Then the next one is your profile view height, which is also automatic. It's going to make sure it picks the minimum point and the maximum point of your design. So we go to next. Here we have your profile display options. For now, the only profile view you have is just your EG surface. So pipe network, we are not bothered about this. Data band. Your data band is just like something like a strip which is always below your profile view that tells you the information of what is in your profile view. Like now we have the EG, FG elevations and station. EG is the existing ground, FG is the finished ground elevation, and then the stations. So you get to see how all this works later on. So next, then click on create profile view. Create profile view. So once I click on create profile view, I go to a to a place not far from my plan, but a little bit away, then drop just to see what I have. So you can see this road 1 profile has the name given to it, road 1 profile. You can see this is the existing ground along my road. corridor. See to the end. So now I'm licensed to start the design of this road, because now I already have an impression of what the ground is around where my road alignment passes through. So now I have to think about what I need to do as a road infrastructure design engineer to implement the design of this road. So either way, I just select this, select your profile view, the dynamic ribbon comes up. On your dynamic ribbon you can see what we have. We have the launchpad, modify, but this is what I'm actually interested in now, profile creation tools. So on the profile creation tools, the alignment name is road 1, and then on your name this is going to be your designed road 1. I call it designed profile. Design profile road 1. Design profile road 1. So under your profile style, you pick the design profile. Your profile label, you leave it to the complete label set. Your design criteria, just leave it as the case may be. Leave it to default. Just leave it to default. So click on OK. So immediately you click on OK, the profile tools creation dialog box or tab comes up on your screen. So this is what you're actually going to be using to create your design profile. Make sure your existing surface profile is well zoomed on your interface for you to actually see the full band.
How come I want to select this?
Like, it's because you selected it. So make sure it's always what's called is your view area that you can see it very well, because we're about to start the design of this particular road corridor. So I just go to the first one, which is my draw tangent with curves. I click on the drop down. I do my curve settings. I do my curve settings. On my curve settings is parabolic. It's there I use my K value or I use my length. I adopt my K value. I check K value. So once I check K value, I leave it to the 50/50 it is.
What's K value?
K value is just a constant you being used in what's called the road profile designs. So use K values. So once I select 50, that means my K values must not exceed 50, because it's a core parameters. You get to read those in standards too. FCDA has their own K value standard. Make sure works has their own K value standard. So once they give you those K values, you input them here and then you design with them. Once you violate these K values, the software will tell you you violated it and you have to adjust your K value. It helps us to maintain the grade in which you actually design our roads. So you still have to take up some road design standards to actually understand what all this means. So I click on my OK now. After clicking on OK and I've done my curve settings, then I just go to draw tangent with curves. Draw tangent with curves. Draw tangent with curves. So I go to my drawing, I go to the first point where the road starts from. I click on it. So now I turn off my snap, because it might be disturbing me to be selecting points I don't want to select. So I turn off my snap. So I start doing my design using my basic instinct to actually do the design, having the minimum cut and fill as possible. So I might need to turn on my snap at the end again to make sure it snaps to the end.
this ending part is too elevated.
Sir?
This ending part is too elevated.
The ending part is what?
It's too elevated.
No, we don't see one thing about this place. Looking at this place. This is a possible bridge location.
Bridge?
Yes, this depression. Yeah. There's every tendency because from what you have in your plan, this point is just here. So there's every tendency there's a bridge here. So the grade must actually have to be raised to actually give way for the location of bridge around there. So the grade is always higher up around there. You backfill. So those are the things that comes into play whenever you are doing your design. You don't just jump into design like one. There are some things that actually there are some instincts that we actually have to bring into play. You can finish the design and come back to be adjusting them later on. Yeah. You can turn on your snaps to be able to snap it back to the end point. So like I'm doing, I can always come back to. So that's just that about the design. Well, all this percentage trade now, which is obviously might decide to introduce a page break here. I decide to introduce a grade break.
A page break.
Grade break. What I mean by grade break, grade is just like slope. I might decide this slope is too much. I might decide to break this slope. Yes, sir. But introduce PVI now. Point of vertical intersection. Just to make sure I break this slope around somewhere here.
There could be a lot of cuts in it.
Yeah, something like that. I'm just trying to achieve something here.
Yes, because even looking at it from here, you know that for cars to climb up to this level,
it will be very, very difficult. Yes. So it's that you do your magic right from here.
So those cuts, is it the grader that did the cutting?
No. Grader doesn't do cutting.
What are those cutting?
What's your bulldozer meant for? Your bulldozer is there, your excavator is there.
Which one is that one that is?
Excavator.
That is excavator.
Yes. The excavator is there to do it, so many of your cuttings. Your bulldozer to clear anything that is obstructing.
The bulldozer is that one that has a big side.
Yes. Moves like that. The grader is just meant for you to spread.
That one that's under.
Yeah. That's a grader. It spreads, it scraps, then enables it to compact. Although that's how we just go around this. So one thing we always do again to clean up this, so as for you to be able to see all these details very well, you might just do something. Select this profile view. Select the profile view. Right click. Go to edit profile view style. Then on your grid, go to your grid tab, then you click on clip vertical, clip horizontal, clip to highest profile, clip to highest profile. So you click on apply and OK. So this allows you to see a clean view of a design. So you get.
Yeah.
So that's how that flows now. So by now you can actually see what we're doing, adjusting up and down. You can easily see what you're actually doing around here. You can see my K value is pegged at 50. Sometimes it might be lower at some point. Like here now my K value is 20 around here. At the point where it violates that 50, it will tell me like it has violated that particular information. So the next one too, you just do for the next one, which is for the second road, the same way we did for the first. So first create the surface profile. Create the surface profile. That's row 2. Make sure you select the row 2. Don't do the mistake of drawing profile view. Row 2. Next. 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 Let's get the one next. Create. Okay, we'll just create at the bottom there. So you can see this row 2 profile. Okay, it's too close to your this. You can just select, don't delete it, just select it. See the way I'm going to select this one. Just select it like this and use your normal move command to move it. So then you select the profile view, profile creation tools, and you call it design profile row 2. Design profile row 2. Pick design profile, completely best set.
What do you reckon?
I want to design this profile, the same design we did for this. So you go to profile creation tools.
That's profile.
Design profile, yes. So we go turn the curves, turn on my snaps. Turn on my material.
Do you have to touch the curve settings?
Is it?
No,
it's already, once you do the first one, the curve setting is permanent, so you don't have to disturb yourself about the curve setting anymore.
No one thing about this design.
Yeah? Let me tell you one thing about design. Although that's based on experience. Whenever you're designing, see what I selected, but this is my start point. See my start point. My next point I'm dropping is almost at 200 meters. Here you get. The next point I dropped was almost at 200 meters. I didn't drop at 50 meters because you can't expect a sudden change in grade whenever you're traversing a road or 50 meters. 50 meters is just like here to the front of that gate. So you don't expect a sudden change of road, because if I'm saying a change of maybe my 1% now within this particular 1% now coming down up to this point, which is 120 meters, is okay. But if I'm coming down in a speed of 40 meters or so like that, with this particular grade, it's going to be a very steep grade. So we always think about going not less than, let's say, 100 meters. You drop, then you think about the next best point to actually drop. So just don't drop at close intervals. Whenever you are designing, you don't drop at close intervals, and as well as taking into consideration your slope, grades, and so on like that. So that's how we actually design. Not that we just drop. No.
But somewhere like this, there's going to be this bridge here.
Yes, it's possible bridge location on that place. Yes.
But if okay, let me finish it.
Okay. So what's the question?
Okay, you said there will be possible bridge at this point.
Yes, yes. If we check that on your layout, is it as a location? This is 225. I check. So this 220, 225. This is the possible location of the bridge between 200 and 220. You see?
That's this.
Yes, between 200 and 220. So, the things you always look out for.
So, the bridge we start from here.
No, doesn't mean the bridge will start from there. Look from here. From here. What's the height from here to here? See this height. This is 380. This is 2 meters. This is what? This is 2 meters. This is 2. This is 4 meters. And this is 6 meters. So if my bridge is of a height of 6 meters, see where my deck will be. This 6 meters. Tracing it to this point. So that means the grade of my bridge will be at this point. The grade of my bridge will be at this 6 meters. So every other places around there will be backfilled to actually meet up with the. I don't know if you've seen where they're constructing a bridge. The bridge will be isolated. They will have to backfill because there will be a retaining wall at this thing. Yes, there's a side of the bridge that will be a retaining wall here. Retaining wall here. Then they put the deck. So for such structures. So that's this thing. So now going into this properly now, let's go how we can actually play around all this. Let's see what we can achieve. So looking at what we have here. Looking at what we have here, we have this to be at 20 meters, but our alignment is at 25. So let's correct that on this particular platform. Although there's something we always do, like for me now, who has been using these tools for a long time, I already have the templates whereby if I'm designing, I don't have to be doing all this all over and all over, because once I'm designing, everything is already programmed for me. So I do it's on 25. I don't need to go back and forth to check or to confirm, because I've already programmed mine. I want to be like that. So now the first thing I do is edit profile view style. I go to my horizontal axis. can see your interval is at what, 20.
Yeah.
So I change that to 25 meters. So you see where I am again. I change my top. You know there's a bottom tick, there's a top tick. See where I have it? Bottom, top, bottom, top. So I change to top again. I put top to 20 and 25, sorry. So I change back to bottom. So I can click my apply and OK. So you can go check what you have. Is at 25. Well, if you notice, this is the band we're talking about. This is the band we're actually talking about earlier. The band was EG, FG, station. This is EG, this is FG, and this is the station. But the EG and FG is supposed not to be of the same value, because the EG is the existing ground condition, your FG is your designed or finished grade. So this has to be different value, but here it's telling us the same value. So what's happening? We have to correct that also. So this one we just correct it on our profile view properties. Profile view properties, you go to your band tab, then you change your profile 2 to your design profile. Change your profile 2. You scroll to the front. Change profile 2 to your band tab. Yes, profile 2 to design, then apply OK. So you do for the other one too. Change the profile 2. So now you notice the difference in the values of your design profile to the existing. So you can check, you can look around, check your profile, you can see they are different, but this is 391, this is 390, 392, and so on and so forth. Are we good? Okay. So subsequently there are so many other information that comes along with this profile view design. If you look at let me see this one I have here. Let's see one of these PDF. I don't open this one. Let's see. Let me show you typical sample what I'm actually talking about. What's this product? Save the design. I didn't turn off this PDF. I want to run the PDF. Okay. Yeah, so this is a typical design we have. You can see this is obviously different from what you saw earlier. This band is different from this band. You can see the difference. This is what, maybe this is the one they use way outside where they come from, but in Nigeria it is the type of band we actually use. So we actually sat down to customize this particular product to suit what we use here. So that's why we have something like this. So we went through how we actually do this. Maybe probably that's the first thing we do in our next class. How we actually customize this advanced style to fit what we have in that particular presentation we had there, because that was the finished design. But subsequently, before we end today, we run through the profile settings, how we came up with this, and we can actually create our own profile view settings. So number one, let's go select this profile view, right click, profile view properties, then you go to your arch, you go to your arch. So at this point we want to arch our cut and fill area. I select cut area and I select fill area. You click on apply and OK. So you can see your program. It should be the first one. So it's going to arch where it's going to be your cut, then where it's going to be your fill, then where you'll be having cut will be red. So that's how it works. So same thing goes for these two, depending on, this is my cut, this is my fill. Let's wait, this is cut, my cut is green, my fill is red, so I have to change this, my upper boundary and lower boundary. Let me see. There's one thing you have to get it right. If my lower boundary, this is my upper boundary, this is the finished, and this is the existing. Then I have to fill it. Okay, this is right. If my upper boundary is my AG and my lower boundary is this, so I have to cut my upper boundary to form the lower. So if my upper boundary is my design and this, so I have to fill my lower to meet it. Okay, it's right, it's correct. So this is what we are. So those are the things you actually think of. Any question? Okay. So that's that about having our arches on the profile view to actually tell us our cut area and our fill area. Then what else can I actually tell us about this profile view? So selecting my profile view, then going to the profile view properties. Number one thing you see on the tab is the information tab. This gives you the profile view name. I'm having row 24 is because when we're creating the profile view, we've created some profile views which we deleted, and the program actually automates the creation of profile views by giving it numbers itself. So that's why you'll be seeing 24, seeing 13, or as the case may be. That's why this whole thing, I might decide to change it to whatever I like. That too. Click on apply. Yes. So, and then this is where you have the profile view style. Assuming we have the ones we preloaded, you can see the stack here. Then the next tab is the station tab. This gives you the information of the changes of that particular profile view, the starting and the end. Then the next one, which is the elevation, it gives you the maximum and minimum height of your profile view, of your profile in the profile view rather. And these are the profiles. We have the design profile and we have the existing ground profile. So these are just those informations, and here is the band, and the last one, which is the arch. So same way we did for the profile view properties, now we go to the profile view style. Profile view style. Profile view style. Profile view style. On the profile view style, we have the name, which is profile view. We have the graph. Just like you drawing a graph in a conventional or manual way, same thing applies to this. Applies to this program. The graph has its own scale. this is a graph. The plotting graph has its own scale, which is relative to the working environment graph. Sorry. Which is relative to the working environment graph. So like this one, and the exaggeration of this is just by 10, because 10 by this 100 makes the 1000 scale which we are using. So that's why we have that 10 exaggeration. So this graph is a little bit exaggerated by just 10, a little bit bigger than the normal size by just 10. So that's just that. So your profile view creation, the direction you want it, depending on the country, you will read from left to right. It's from right to left. You select right to left for your graph. So your grading, this was where we came in to do our clipping the other time. Clip to highest, clip to highest. If you want to omit, you can omit, and if you don't want to omit, you can leave that. Side to an annotation, what you have here, your profile view name, you might decide to make it bigger. I want it to be bigger. I'm giving it 15. If you want it to be bigger, then you click apply. You can see the effect almost immediately. So if you want to make it bigger, do that. If you want to change the font style, you can see what I'm going to do to change the font style. This is more or less like going in depth now to format this particular. So you come here, you highlight, then you come here to select the font you want. You can see the various. I usually use Andalus. Use Andalus, make it bold. If I want to change the color, I might change the color. I leave the color by block, and I click apply.
Let's
go to format.
Change from simplex to.
So any font, if I use Times New Roman, I always use Andalus. That's my own format. If you want to, you can type A to look for AN. Look for it. Oh. So you click apply, and then you see the effect as you click on apply. So same thing goes to the horizontal axis. On the horizontal axis, you might decide to change your label ticks for your station, for anything at all. Just come here, go to format, change it to Andalus. So this is just like you're not customizing the program, customizing the settings to fit your style. Minor ticks, just do for format, so effects. Click on apply. And we'll see. So for your vertical ticks, just change the format only, not touching a Latin from there, just a text format. see. We have this corrected, the road corrected, everything corrected. So subsequently, every other thing on your profile view style, I just the display where you turn off layers for some and turn sorry aperture is affected.
Have you heard of SketchUp?
SketchUp, Google SketchUp, yeah. It's for model.
Do you have it?
No, I don't have it. It's basically for modeling and modeling basically.
What modeling?
Hmm?
What do you mean by modeling?
Okay, what is meant by modeling? 3Ds. Model buildings, chairs, anything you could think of at all, just like AutoCAD. That's how SketchUp works.
But you can use it to design houses.
That's modeling houses, yes.
Yes. I want to learn it because I'm passing it, I got structure and goes into this thing, like structural aspect.
The what?
Structural aspect.
Of SketchUp.
Of structures. So I've learned SketchUp.
I will advise you to go learn Revit there.
I really know AutoCAD.
AutoCAD is not. But Revit is.
Everyone says this Revit. I don't like Revit.
You don't like Revit?
I find that. Maybe it's because I said it's AutoCAD, so.
Maybe. Revit is more powerful than that. Let me show you. This is.
I don't like the background effects, the interface and everything.
That is why these are works of Revit.
Yes, without the effect of 3D Max or anything.
No, render, post-render in 3D Max. These are Revit works. It's way better than AutoCAD. I know AutoCAD, I know Revit. I don't go into architectural works. I was almost in that lane before, so I had so many things in my hand that to do that. So I always give my architect, if I need models today now, if I can sketch it and send it to my architect, he will give me in 2 days to give the models, rendered everything. And I'll use it in my project. That's all. So to display, turn off, turn on, do some other this in here. This is what you do. But most it's advisable not to actually touch anything on the display for your profile view. Just leave it like that. That's about your profile view. Yeah. So let's start with the settings. Let me just, because we've actually worked from point to surface to alignment, then to profile view. So we tend to explore the settings in the next few minutes now. We want to explore the settings. So when we at the leisure time, after you understand how to use the software, then you must feel convinced you want to start customizing all the settings you want to. So sort of for you to be able to go in through the back door, do what you want to do with the program, then come out again and you feel you are doing it right. So let's go to the settings tab. We're leaving Prospector now. We're not actually doing any design again. We just want to explore the settings. We'll call it a day. So we'll pick up from here. Because the next class, what we'll be starting with now is our intersection, then go to our assembly, then corridor. So settings. On the general settings, we have the general. Yeah, initially when we started this project, I forgot to do something which is very, very vital when we actually want to send this design out into InfraWorks, and that's giving the coordinates of the project. Whenever you get your data from your software, the software gives you a reference data. We call it a reference datum or a reference coordinate, which he actually used to pick up his survey information or survey data from site. So those coordinates or datum is what you actually input here. So to do that, you right click, you activate your settings tab, you right click on your drawing name. Maybe I haven't saved it, that's why I'm having 22, but I've saved it with a particular name. It's the name that I'm going to add here. So I have this name, edit drawing settings. Edit drawing settings on my unit and zone tab. Unit and zone tab. I go to my zone categories, then I pick MENA. I look for Nigeria rather. From drop down I look for Nigeria, because what we always use here is Nigeria. What is it? Then once I get to Nigeria, I pick MENA UTM zone 32. UTM zone 32, you pick Nigeria, MENA, UTM zone 32. Now you click on the drop down, then you click on the apply, and OK.
Is it because connected internet? Everybody's going to MENA?
No, mine is not connected now. The internet is not working again.
So how was the MENA?
No, it will come there automatically itself.
Okay, because of the point.
Not because of the point. You pick Nigeria. So on the database of this program, on the datum database, they've already programmed all this there. It's in the software program already.
Yes, why MENA?
That's the reference datum of Nigeria.
MENA, that's the national
Niger State.
Niger State, sorry.
Yes.
So I can't see data there also.
No. You always use, if you see the drop down, go there again. Go check your drop down. Pick Nigeria. Yes, Nigeria. You can see East Belt, Middle Belt, West Belt. You can see all those ones. East Belt, Middle Belt. So that is where all these Delta, Niger, everything falls on. So the person that's going to give you the reference coordinate is your software. If he's picking his information, his base station or his total station, the reference point is making use of. Once it gives you, it's going to tell you whether it's falling in any of this category. So it's not like the program or the software is giving us that. So you get. Yeah, so that's how we came up about that. So you pick this, pick my apply, and click on OK.
You're driving at full speed.
Yes,
the power line came from the movie.
Yesterday there were 3 doing race yesterday. I went out.
But do you alight?
You want to stop there? Maybe they are driving too. You are driving your car, they are driving your bike. So
that's a serious.
They have license to drive that, ride rather.
They must compete.
They won't tell you they are competing now. You see 3 bikes running and then you like, what else do you expect that do? So that is that about this. Then the general settings. Under here you can see all the labels, marker styles. Here you can actually tweak and go about any of your marker styles at all. They are very much. So all I just want to do is just show you not about, because if you actually want to go into this editing them from here, you might not get to understand where you're going to be meeting them in your design interface. So this is just to show you where all this is, because whenever you are working on a design and you get to meet them, you know where you can actually come to find them. Multipurpose label styles. Marker, expand your marker styles. So you see all of them like that. There are so much for you to actually comprehend. Same thing goes with features, feature lines, projection lines, code set styles, link styles, shape styles. So all these styles are just there. Then the label styles, you see the notes, general notes, line notes, bearing over distance, and so on and so forth. So all this you get to see them during design. Then you know where you can actually come down here to customize them as the case may be. Especially when I get to typical cross section, you get to see where all this may actually play out, because that time you play with the size, you turn some off, you turn some on to actually display certain information for your design purpose. So the next one is your point. You can see your point styles, all these basic that we were selecting earlier. You can see them, these are how they come out. You can see this is a particular basic marker style. If I should go to benchmark, you see how a benchmark will appear. This is typical, just you expand your point styles. You expand point styles. So you right click on basic edit, so you get to see how you can actually modify them. So this is the back door where you can actually come, change the style, change the color, change anything you want about them at all. So if you are not satisfied with what you are seeing, this is where you can actually come, change anything you want to change about all these marker styles. Then go to surface. Same thing goes with surface styles. Initially when we were talking about those contours, so here you can actually create your own. You can add to this, just write new surface style. So here you can start doing some of your editing. But one thing I always advise people is you use the existing one to create a new one. So by using that, you have an idea of how you want to move. Like let's take for example, let's pick on this 1x5 and convert this 1x5 to 0.2 and 1 meter contour. So this is what I'm going to do. I right click, I tell my program to copy. I right click and I tell it to copy.
Yeah, I think good.
I right click on any existing one, because I want to use an existing one to form my new style. So I right click and I use copy. So on the name, I change the name to 0.2 meter by 1 meter. Still going to be background. So under description, this the surface contour at 0.2 and 1 meter background. So I go to my border. I'm not going to change anything on the border. I won't change anything on my border. Then I go to my contour. Here, this is where I want to change. My contour initially was 1x5. Now I need to change it to here at 0.2 to 1. 0.2 to 1. See, this my system just running out. 0.2 to 1. So once you have that, every other thing that you need to change there is nothing, and all I just have to do is make sure my grid smoothing is, you turn on your contour smoothing, turn on my contour smoothing, put it to true.
What do you think?
Expand your contour smoothing, expand the contour smoothing. From false, change it to true. So I drag the slide bar to the highest. Then every other thing is just the same way you want it. You don't need to stress yourself about it. Apply and OK. So from the list you can now see your 0.2 by 0.2. So if I want to apply it on my surface now, all I just have to do is to select my surface, go to the surface properties and change it to the 0.2 by 0.2 background. Click my apply and click my OK. So you can see my contour is way closer. I have a very close contour spacing. So that's how it works. So let me just return it back to the number one that I even want it to be. Sorry, good. No, this is 5 by 25. No, I want. Yeah. So that's that about the surface styles, and subsequently there are other labels. Yeah, that reminds me, contour labels and so on. You can see the contour labels. You can modify them as the case may be. You can make it bigger or smaller. So let's do something. Let's label the contours. No, the contour is just the there is no label giving us the information about this contour, so that makes these contours incomplete. So how do we label a contour? You go to your annotate, go to add labels, not tables this time. Add labels.
Is it the arrow or the photo?
The arrows. Click on the arrow, then you go to surface label, and go to add contour multiple at interval. Add contour multiple, that's the last one. So it's telling me to pick the first point. So this is what I always do. I always make sure I pick a point whereby it will run across my entire surface. So it's asking for the interval in which I want my distance to run. I want it at 50-50. I'll allow it to generate, so you can see. Yes. No, just 50. Just type 50.
I can delete this line, sir.
Yes, you can delete that line that you drew.
Yes, sir.
So you can zoom in on it to check your contour labels. So you can see the contour label being labeled at 50-50 interval. As we add it at 100-100, it's going to give you at 100-100 interval. So still on our settings, if I now decide to edit my contours here on this label, so right click, edit major label, you'll now be seeing the effect. Surface. Always collapse all this back, so I don't have to go through the stress of finding what. Your surface.
Okay.
No, collapse surface styles, expand label styles, contour, expand contour. So we now want to edit existing major labels. Existing major labels. So by default, you see the information general, the layout tab. On your layout tab, we want to increase the height, the text height, change it to 5. Change the text height to 5. Then under the content, you click at the ellipse button. You call this ellipse button. See the content. I'm on the content now. Click content and you click on the ellipse button right in front of the content.
So where's the content?
You click on the ellipse button. So the same thing we did for those profile. We highlight and you format it. Andalus. Good. Okay. So you click on apply and okay. So I do the same thing for the minor 5. No, you know what's wrong? That video recording, that thing runs the system like, so I think we'll call it a day before it ends, and then to be able to do anything again. So at this point, we just continue from here in the next class because it's already on there. It's almost